Welcome to this video on physics revision. In this session, we will break down the concept of forces, covering everything from contact and non-contact forces to resultant forces and free body diagrams. Here is our revision roadmap. We will begin by defining what a force is, then examine contact forces like friction, air resistance, and tension. We will also cover non-contact forces, including gravity and magnetism, before finishing with resultant forces. So what is a force? It is simply a push or a pull acting on an object. Forces can change an object's shape, speed, or direction. They are measured in newtons, named after Sir Isaac Newton, and always act between two objects. Forces are measured in newtons, abbreviated with a capital N. 1 newton is roughly the weight of a small apple. It is important to always include this unit in your exam answers to avoid unnecessary point deductions. Moving on to Chapter 1. Contact forces. These are forces that only act when two objects are physically touching each other. There are 4 main contact forces you should know for your GCSE: friction, air resistance, tension, and the normal contact force. Remember, if the objects separate, the contact force disappears. Friction is a contact force that opposes sliding motion between surfaces. While it can be useful, like when your shoes grip the floor, it can also cause wear on machinery. The rougher the surface, the greater the friction. Air resistance, also known as drag, is the force acting on objects moving through the air. It is affected by the object's speed, surface area, and shape. A streamlined shape will experience less drag. Tension is the pulling force transmitted through ropes, strings, or cables when they are pulled tight. It acts along the length of the material and pulls objects towards each other. The normal contact force, sometimes called the reaction force, acts between two surfaces in contact. It is always perpendicular to the surface. For instance, when a book sits on a table, the table pushes upward to prevent the book from passing through. In Chapter 2, we look at non-contact forces. These are forces that act between objects without them physically touching, often over a distance. Non-contact forces act through fields. The 3 main ones to remember are gravity, magnetic force, and electrostatic force. Gravity is an attractive force acting between objects with mass. On Earth, it pulls objects downward. Note the key distinction. Mass is measured in kilograms and stays the same, while weight is a force measured in newtons that depends on gravitational strength. Magnetic forces can attract or repel based on pole orientation. Unlike poles attract, while like poles repel, magnets create a magnetic field that allows them to exert these forces without touching. Finally, electrostatic forces act between electrically charged objects. Positive and negative charges interact, where like charges repel and opposites attract. These forces work through an electric field. Let's quickly compare contact and non-contact forces. Contact forces require physical touch and do not act through fields, whereas non-contact forces act at a distance through fields like gravity or magnetism. Moving to Chapter 3, Balanced and Unbalanced Forces. Understanding how these forces interact is key to predicting an object's motion. Balanced forces occur when individual forces cancel each other out, leading to a resultant force of 0. If forces are balanced, an object will remain stationary or continue moving at a constant speed in a straight line. Conversely, unbalanced forces produce a non-zero resultant force. This causes a change in motion, meaning the object may speed up, slow down, or change its direction. Consider a tug of war. When both sides pull with equal force, the rope is balanced and stays put. If one team pulls harder, the force becomes unbalanced, causing the rope to accelerate toward the stronger team. Chapter 4 focuses on the resultant force. This is the single overall force that represents the combined effect of all individual forces acting on an object. To find the resultant force, consider the direction of the forces. If they act in the same direction, add them together. If they act in opposite directions, subtract the smaller force from the larger one. Here are some examples of calculating resultant forces. Whether adding 2 forces pushing the same way, or subtracting forces acting in opposition, the result determines the final net pull or push. The resultant force dictates an object's future motion. A 0 resultant means no change, while any non-zero value will cause the object to accelerate in that direction. In Chapter 5, we look at representing these forces using arrows. Diagrams help us visualize the direction and magnitude of the forces involved. When drawing force arrows, remember, the arrow's length represents the magnitude, while the arrowhead indicates the direction. Always label the force type and its value in newtons for clarity. Scale is important. Keep lengths proportional to the force size. Start arrows from the object's center and point them outward. If forces are balanced, opposing arrows must be exactly equal in length. Chapter 6 covers free body diagrams, or FBDs. These are essential for showing every single force acting on an object in a simplified, clear manner. In an FBD, the object is drawn simply, like a dot or box. It is crucial to only show forces acting on the object, not forces the object exerts on its surroundings. To draw one, start by placing your object in the center, identify every force acting on it, draw your proportional arrows pointing away from the center, and label them clearly. This will give you a complete picture for your physics problems. Let's look at a free body diagram for a falling ball. We have weight acting downward due to gravity, and air resistance acting upward, opposing the motion. This diagram helps us understand how the balance of forces changes as the ball speeds up. For a stationary book, the weight pulls down, and the table pushes up with an equal normal contact force. Since these forces are balanced with equal lengths, the resultant force is zero, and the book remains at rest. Common mistakes in free body diagrams include showing reaction forces the object exerts on others, failing to keep arrow lengths proportional, and omitting labels. Remember, only show forces acting on the object, ensure length reflects magnitude, and always name and value your forces. Exam focus. An object's motion is entirely governed by the resultant force acting on it. Mastering this relationship is central to success in your GCSE Physics forces questions. This visual illustrates how the resultant force directly dictates motion. Whether an object is stationary, accelerating, or moving at a constant speed, the state of the resultant force tells the full story. Here is the big picture summary. Every force you encounter in GCSE Physics will be either a contact force, like friction, air resistance, or tension, or a non-contact force. Use this structure to organize your thinking during exams. Here's a quick reference for key vocabulary. We have defined forces, contact and non-contact types, resultant force, free body diagrams, and balanced forces. All of these are measured in newtons. For your exams, remember these tips. Balanced forces mean zero resultant force. Always label your force arrows with names and values in newtons. Include the direction when stating resultant force, and be prepared to classify forces as contact or non-contact. Let's finish with some quick-fire recap questions. Can you define a force? List contact and non-contact forces. Calculate a resultant. Explain what happens when the resultant force is zero. Or recall what must be included on an FBD. You've got this. You have now revised all the key concepts for your exam. From identifying forces to drawing diagrams and calculating resultants, you have the tools to perform with confidence.